Hello, so welcome to my problem solving session. This is your problem number 18 from chapter 27. Someone asked me for solving this one. So this is basically the 2 voltage source circuit which is contained over here. So this is actually the E1 and this is actually the E2, and it has the 2 loop actually. So this is the loop number 1 and this is the loop number 2. So they ask actually in the problem to find out the voltage difference between the point D and point C, which is actually the voltage of across this resistor R2. So they also given that the direction of this current through the circuit. This is the I1, this is the I3, and this is the I2. So and also given that voltage source E1 is the 4 volt, E2 actually the 1 volt, R1, R2, which is the resistor actually this one R1 and this is R2 and this is R2, that is given. So they asked me to find out only the voltage difference between the point D and C, which is actually that one. So that's mean if I can find out the current I2, then multiply by the R2, that's will be actually the voltage drop between the point D and C. So that's mean my first target would be to find out the current I2, then I will multiply by the resistor R2, that will give me actually the voltage drop between the point D and C. Fine. So I have to use the 2 formula over here. One is the charge conservation, which is the KCL, Kirchhoff current law, and second one actually the KVL, which is the energy conservation, Kirchhoff voltage law actually. If you closely observe at the point D, actually the I1 is incoming and I3 is also incoming. So that's why I can write down this formula actually, that I1 plus I3 actually will be the I2. So this is actually the key point. So solving this circuit actually, what I'm going to do, basically that choose 2 loop, which is actually the D, A, B and D. So this is will be my loop number 1, it's a closed loop, and second loop I will follow from D, B, C, and again I will come to the D. To following these 2 paths actually I will follow that convention I told you into that class. Actually if I go in the direction of the current, voltage drop across the resistor with the negative. If I move in the opposite direction of the current, voltage drop across the resistor would be the positive. I will also follow that convention over here. So that's why if I start from that loop D, A, B, D loop, actually that's when I'm going to start from point D, throw out that path and again come out that point. So to following this path actually throughout the R1, I'll move in the direction of the opposite of the I1. So that's why the voltage drop across that resistor would be the positive, and through the R3 I'll follow the direction of the I3. So that's why the voltage drop across this R3 would be the negative. That's thing I write over here. Look at this. This is actually the voltage drop I1 R1 minus IE1, which is actually the voltage drop that path, and also minus I3 R3, which is actually the voltage drop across this one. So now you can solve this one because this is actually the linear equation, I1 R1 minus I1, and I just replace this R3 from this equation. So R3 would be I2 minus I1. So I will just find out this equation. Into that line I just put the value of the resistor of R and the value of the E1. So if you solve this one, so you will find out this equation. So this is be 15 I1 minus 5 I2 minus 4 equal to the 0. So this is actually the equation number 1 that I find from this loop number 1. Fine. So now for the second loop, what I'm going to do for the second loop, basically I will start from that point. So look at this over here. So this is actually I go from D, B, C and D. So again I will follow that one. If I move in the direction of the current, voltage drop across the resistor will be the negative. If I move in the opposite direction of the current, voltage drop across the resistor would be the positive. So that's why if you start from that point, what I will write from this equation over here for the loop D, B, C, D. So that's mean point D, B, C, again that D. So that's why I'll first phase this resistor R3. It should be basically that I3 R3, then voltage drop across this one, which is will be the difference would be positive over here, because this is the final minus initial, this will be the positive quantity. So that's why I find out the plus E2. And for the resistor R2, which is actually I am following in the opposite direction of that current I2, so that's why this should be the minus I2 R2 equal to the 0. Now you can again replace that resistor, basically the current I3, which will be I2 minus I1 into R3 plus I2 plus this equation. Now you can just put the value of this resistor. So if you put that resistor, what we will find out, you will find the minus 5 I1 plus 15 I2 plus 1 equal to the 0. Now I have these two equation, I have two unknowns, so I am going to solve this equation number 1 and equation number 2 basically. So what I did over here, I just multiplied this equation by 3, so to actually add them equation 2 and 1 actually. So that's why I just multiply this is equation number, this equation multiply by the 3, so that's a 15 I1 45 I2 plus 3 equal to the 0. I just multiply this equation by 3. Now I am going to just add these two equations to find out that solution. Hold on, I just turn over this page, because my video is not too professional basically. I am just trying to solve this one. So this is the second line actually over here. You can find out. So now I just add this equation 1 and 2. What I find, 15 I1 minus 5 I2 minus 4 equal to 0, which is equation number 1, and second equation which I multiply by the 3, which become minus 15 I1 plus 45 I2 plus 3 equal to 0. Now if you add then this minus 15 I1 and plus 15 I1 will be cancelled out. I will find out 40 I2 minus 1 would be equal to 0. Then I can find out which is I2 would be the 1 over 40. It's going to be actually the 0.025 ampere, which is actually the current into that branch that I want to find out, because this is the current. If I can find out the I2, then I can find out the voltage drop across would be the resistor R2, which would be actually the voltage drop between the point D and C. So that's why I find out the value of I2 actually the 0.25 ampere. Then I write down VD minus BC would be the minus I2 R2, which would be basically 0.025 minus 10 actually, which will give you actually the plus 0.25 volt actually, and it is plus basically this one actually the higher potential. You can also find out the direction of that I2, because the I2 is going to into that direction. So that's why this is, if you take the difference between the point D and C, it should be basically that this is actually the higher potential. So that's why you will find out that this should be actually the voltage drop across that R2 would be going to be the basically that 0.25 volt, which is actually your answer. So this is the end of this problem number 18 from chapter 27. If you have any question, you can ask me onto online or any by the message. Thank you very much.